Hi guys! In the previous videos, we learned how to calculate enthalpy change using calorimetry and Hess's law. In today's video, we'll be learning how to calculate enthalpy change using enthalpy of formation. Now, first of all, what's enthalpy of formation? Enthalpy of formation is nothing but the amount of energy required to form this particular compound. So if I say delta H naught F of Fe2O3 solid, that means if I want to form 1 mole of Fe2O3 solid, I need negative 824.2 kilojoules of energy to be lost. Because it's minus, so that's why we have to say it's lost. Similarly, enthalpy of formation of carbon dioxide, this is a gaseous carbon dioxide, requires 393.5 kilojoules of energy to be lost. And carbon monoxide formation requires 110 kilojoules of energy to be lost. So make sure that you need to look at the states, because for example, if it's water, then water liquid will have a different delta H naught F, and water gaseous, which is water vapor, will have a different delta H naught F. Now the question wants you to find out the enthalpy change of Fe2O3 plus 3 carbon monoxide, then give you 3 carbon dioxide plus 2 iron. What is the delta H? This is our goal. If I want to find out delta H for this, all I have to do is I have to use my enthalpy of formations. Now you would see that I've been given enthalpy of formation of this. I've been given for carbon monoxide, I've been given for carbon dioxide, but I've not been given anything for this. Okay, so always remember, when anything is present in its original state, for example, iron solid is the natural state of iron. So natural state means you're not forming it. If you're not forming it, the enthalpy change for any element in its natural state is going to be 0, because you're not spending any energy for it. Similarly, if I want to find out enthalpy change for oxygen, and oxygen O2 is the natural state of oxygen, it is going to be 0. So always remember, your natural states enthalpy formation is always 0. So technically this is also given to us, so this is also known to us. Now, what is the formula for finding delta H using delta H naught F values? It's basically sum total of number of delta H naught F of products, so minus number of sum total of delta H naught of reactants. So what do we need technically is we need to find out what is this. This sign means sum total of the number of delta H naught F of products. So my products are carbon dioxide and iron. So first of all, I have to find out sum total of number of delta H naught F of products. This means number of moles. I have been given 1 mole of carbon dioxide. You see, energy per mole. I need to find out for 3 moles. So what would I do is I will just do 3 times delta H naught F of carbon dioxide plus 2 times delta H naught F of iron. Now what is delta H naught F of carbon dioxide? That's negative 393.5 plus this is 0. So all we are going to be left with is 3 times negative 393.5, which is equal to negative 1180.5 kilojoules. I'm not going to write it as per mole because it's no longer for 1 mole. So next is we find out what is the sum total of number of moles of enthalpy of formation of reactants. Now my reactants are iron oxide and 3 moles of carbon monoxide. So my iron oxide is negative 824.2 kilojoules per mole energy, but I have 1 mole. So I'm just going to write it as 1 times delta H naught F of iron oxide plus 3 times delta H naught F of carbon monoxide. What is delta H naught F of iron oxide? That is negative 824.2. What is delta H naught F of carbon monoxide? That is negative 110. All I have to do is just put it on the calculator. So this is what we get. Negative 1154.2 kilojoules. Now the final step is to calculate the delta H of the reaction, and that is equal to sum total of products minus sum total of reactants. Our sum total of products is negative 180.5 minus the sum total of reactants is 1154.2. We put it on the calculator and we get is minus 26.3 kilojoules. So the final delta H is minus 26.3 kilojoules.